Hi guys, I'm Abhijit Esraj and welcome to my Lab 2 video. The subject of this lab is an object falling under gravity. In my case, a table tennis ball. We analyze the motion and extract experimental data using the tracker software. Two cases are modeled accordingly using VPython, one including drag and the other ignoring it. We will analyze both the cases and also compare them. The things we need are a table tennis ball, a smartphone with camera, the tracker software, the Google spreadsheet software, and VIDLE for VPython. I created the presentation using the PowerPoint software. The physics concept involved is the momentum principle, more commonly referred to as Newton's second law. Well, let's get into it. The first case involves an object in free fall, ignoring drag. Here is the Python code for the first case. You can see that I have set the appropriate object properties like the ball's mass. The fnet is set equal to the weight only. Let's run the code and see what happens. You can indeed see that it works as expected. Using the data created in the python test.csv file, the model position versus time graph was created. Here, I have analyzed the video. On the top right side, you can see how the software creates a graph of the y position versus time, and here you can see the experimental data recorded. You can use any spreadsheet software to create a graph of the experimental position versus time. Here is my graph. Now we have both the model position versus time graph and the experimental position versus time graph of the object ignoring drag. By combining both the graphs, we get this graph. Now, we can also use VPython to extract velocity data for this case. Using the extracted velocity data, we can create the following graph of velocity versus time graph of the object ignoring drag. Now, let's see the second case. Again, we can use VPython to model this case involving drag. Let's see the code. Again, you can see that I have set the appropriate system properties. I have found a suitable value for the proportionality constant of drag force. Let's run the code and see what happens. Again, you can see that it works as expected. Using the appropriate motion data from the python test.csv file, we can create this graph. The model position versus time graph of the object involving drag. Here is the experimental data graph from before. By combining the model position versus time graph and the experimental position versus time graph of the object involving drag, we get this graph, the model versus experimental position graph. Again, we can use VPython to extract velocity data, and the velocity versus time graph of the object can be created. Here it is. Now, we can combine the model positions of both the cases, obtaining this graph, which shows the distinctions of both the cases. Combining both the velocity graphs obtained before we get this graph. You can notice that the case involving drag shows the object moving at a lower speed than the other case. Thus you can see that all of this indeed makes sense. That's all. Thank you for watching and see you next time.